This playable browser FPS was written by Meta's new open-weight Muse Glimmer 30B, running locally through llama.cpp. It took 9 minutes and 56 seconds, with no human source edits. But the independent evaluator still returned fail. Here is what the model actually built, what the automated checks proved, and where the evidence contract broke. Meta released Muse Glimmer under Apache 2.0 as a 30 billion parameter model for always-on local agents. We used Unsloth's exact Q8 distribution file, Muse Glimmer 30B UD Q8 KXL.GGUF, on one RTX 4090 and 3 RTX 3090s. The runtime was llama.cpp build 10349, and DFlash was off for this scored agent run. Before asking it to code, we measured the deployment. A fixed greedy request averaged 25.97 tokens per second. DFlash reached 27.39, only 5.45% faster, with 19.41% draft acceptance and about 2.64 gigabytes of extra GPU allocation. Greedy output also changed, so we kept DFlash optional. The same Q8 model loaded with a requested 131,000 token context. A synthetic needle test passed at 65,547 tokens, then again at 120,033 tokens. The longer prefill took 113.5 seconds. This proves distant retrieval in that probe, not broad reasoning quality across the entire context. A 262,000 request was capped back to 131,000 by this server build. For the scored task, Muse Glimmer could list and read files, write only index.html and the source folder, and run fixed build and check commands. It could not execute arbitrary shell commands or edit the evaluator. The recorder was already running before the first model request. This authentic dashboard is time-lapsed and shows only allow-listed tool names, targets, status, and elapsed time. Across 12 model turns, it made 13 tool calls and generated 14,628 tokens. Weighted decode throughput was 25.59 tokens per second. It wrote index.html once and main.js twice, then passed the production build and its visible static checks. The final artifact has a first-person weapon, keyboard and mouse controls, hostile drones, a heads-up display, 3 waves, game over, victory, and restart states. Independent Chrome testing confirmed the canvas, heads-up display, score increase after an enemy defeat, distinct game over and victory states, and no substantive runtime errors. 9 of 11 required checks passed. The 2 failures were observability mismatches. Player position was not exposed in the serializable snapshot, so held key movement could not be compared by coordinates. Restart used a field named state, while the evaluator searched 3 different aliases. The recorded snapshot still shows health 100, score 0, and wave 1 after restart. We preserved the fail instead of patching the source or evaluator. The result is promising but bounded. Muse Glimmer built a recognizable working FPS prototype locally in about 10 minutes, and its agent decode speed matched the standalone benchmark. The visuals are also extremely dark and simple, and a human playability review is still required. Meta is genuinely back in local open models. But a model that can start the work is not yet the same as a model that always returns a polished, independently verifiable product.